Hi students, in the previous class we were discussing about potential energy and we studied that there are three forms of potential energy. In this class we are going to study about gravitational potential energy. You know what is gravitational potential energy? It is the energy associated with the state of separation of two bodies which attract one another through gravitational force. Two bodies are there and they are separated from each other and the force acting between them is gravitational force. The energy is gravitational potential energy stored in it. Or in simple words, we can say it is the energy possessed by a body by the virtue of its position. The energy associated with the body by the virtue of its position. For example, if there is a book lying on a table and the same book is kept on a shelf at a higher level, then definitely potential energy of the book at the higher level on the shelf will be greater than potential energy due to the book on the table. So it is a difference of separation which is stored in the body as potential energy. Now we are going to derive the expression for gravitational potential energy. Okay. Imagine there is a body of mass m lying on a surface, and I'm going to lift the body from the surface to a position at height h. So this is an object which is having a mass m lying at point A on a surface. Okay, so the weight of the body will be acting downwards. Now I want to lift this object and keep it at point B, which is at a height h from point A. So definitely when I am lifting the object, I have to apply some force against the gravitational force acting on the body, isn't it? And that force will be equal to the weight of the body mg. Okay. So the force required to lift the object is equal to weight of the body mg, and therefore the work done by the force in raising the object to a height h is equal to, we know what is the equation for work done is equal to F dot as general expression. Now I am lifting the object in this direction, isn't it? And the object is also getting displaced in the same direction, which means force and displacement, they are parallel to each other. So therefore theta is equal to 0 degree and the work done is equal to Fs cos 0, that is Fs. Now what is the value of F? F is equal to mg, and what is S here? It is a distance travelled which is equal to h. So the equation for work done in lifting the object is mgh, and this work is stored as what? Stored as the potential energy in the body, and we use the alphabet U to represent potential energy. So potential energy is equal to mgh, or gravitational potential energy is equal to mgh. Next, we are going to study about conservation of mechanical energy. Now, you know what is conservation of energy? You will say total energy of a system remains constant. Same we have in the case of mechanical energy, but there is a condition, and that condition is, it states that if conservative forces are doing work, then the total mechanical energy, that is kinetic energy plus potential energy, remains constant. If the work done in for making the object fall down is done with the help of conservative force. What is conservative force? The force is said to be conservative if work done is independent of the path, and also if the total work done will be equal to 0, if it is a cyclic process, which means if the initial point and final point are the same. So mechanical energy is said to be conserved if the work done is by a conservative force, or the total energy, kinetic energy plus potential energy, will be equal to a constant. So let us see whether a freely falling body total mechanical energy is conserved. So conservation of energy, of mechanical energy, in the case of freely falling body. So imagine there is an object placed at height h from the ground level. Okay, this much distance is h. I'm going to call the mass of the body is m. I'm going to call this point as point A. Okay. Now I'm going to make the object fall from point A to the ground level. Okay. The object is now at ground level. This will take as point C. So the distance between A and C is h. Now we are going to find out whether the total energy, mechanical energy, is conserved or remains the same at point A and point C. Also we are going to take an intermediate point between A and C, and also we are going to find out what is the total mechanical energy there. So I am going to take a point here which is at a distance x from point A. I am going to take this point as point B. Now initially my body is at point A, which is at rest, which means the initial velocity is equal to 0. Okay. So case 1, when the object is at point A. And the object is at point A. Now, first we will find out the kinetic energy. I am going to denote kinetic energy with K suffix K. Okay. What is the equation for kinetic energy? Kinetic energy is equal to half mv square. And initially I told you at point A the object is at rest. So V is equal to 0. So kinetic energy is equal to 0. Why? Since velocity is 0 at point A. And what is the potential energy at point A? UA is equal to mgh. Therefore, total energy at point A is equal to Ka, kinetic energy, plus potential energy at point A, which is equal to mgh. So, at point A, the object is having a total energy of mgh. Let us take the case at point B. Okay. Now, I'm going to draw the diagram once more. This distance is h. This is point C. This is intermediate point B. So from point A to point B, the distance is x. Okay. So at point B. Now, at point B, the kinetic energy is Kb is equal to half, and we will call the velocity as Vb square. Velocity at point B. Okay. Now what we are going to do is we are going to find out what is the value of Vb or Vb square. For that, we are going to use the equation of motion. V square minus U square is equal to 2As. Now, in our case, V square, I am going to write Vb square. Now, what is the initial velocity? Initial velocity is 0. So, here U is equal to 0. Also, A is the acceleration. Now, when a body falls down, you know it is falling under the influence of gravity. So, A is acceleration due to gravity, G. And what is the distance traveled from A to B? It is x. So, S is x. So, what is the value for kinetic energy? Kinetic energy at point B is equal to half. Therefore, Vb square is equal to, this is 0. So, 2gx. Therefore, kinetic energy at point B is half m Vb square, which is equal to half m. Instead of Vb square, we can write 2gx into 2gx. Let's cancel, you'll get mgx. Okay, so we got the kinetic energy at point B as Kb is equal to mgx. Also, what's the potential energy? Now, potential energy at point B is equal to, which our expression is mg into height. Now, from this is the ground level. Now, the object is at point B from the ground level, isn't it? And the total distance between maximum height and B is what? H minus x, because this much distance from A to B is x, A to C is h, so from B to C it will be h minus x. So we can write UB is equal to mg into, instead of h, we can write h minus x. Therefore, total energy at point B is equal to kinetic energy plus potential energy, which is equal to mgx plus mg into h minus x. So this will get cancelled. We will get total energy at point B as again mgh, which means at point A and point B the total energy is mgh itself. Now let us take the case at point C. At point C, kinetic energy is Kc is equal to half mvc square. So we have to find out what is Vc, isn't it? So again Vc square minus Q square is equal to 2as. Now A, again it is G. What is S? What is the total distance traveled from point A to point C? Now we are not considering intermediate point. The object is continuously falling down. So total distance traveled from initial position is h. So S is h. So the equation becomes Vc square is equal to 2gh, and hence kinetic energy at point C. Kinetic energy at point C is equal to half mvc square is equal to half m into 2gh, which is equal to mgh. So kinetic energy is mgh and potential energy is what? 0. Why? Because h is equal to 0 since the object is at ground level now. So total energy is so if you take point A, if you take point B, and if you take point C, the energy at that total energy at that point is equal to what? mgh. Why? Initially the object is having maximum potential energy, but as it is falling down, potential energy is decreasing, whereas kinetic energy is increasing because of the increasing velocity. But at each instant, if you take, at each intermediate point you take and you calculate, you will find that the total energy will be always equal to mgh in the case of a freely falling body. So we can say the total mechanical energy or total energy of the system is conserved for a freely falling body. Thank you.